Okay, cool. Today we're going to talk about staking, restaking, and EigenLayer. So this EigenLayer thing, there's been a lot of talk about it over the past year. It's been a pretty big deal, so I'm just going to tell you guys about what it is today. First, to understand it, you kind of need some background on like what staking is and this concept of restaking that EigenLayer uses. So we'll start off by going over some background with like brief overview of proof of stake, what it takes to run a validator on Ethereum, this thing called LSTs, and how we can use that in other cases. And we'll dive into how you can use that for security, which is basically what EigenLayer is doing. And then after, at the end, we'll have a talk from Rohit about risks and repercussions of EigenLayer. So in September 2022, Ethereum moved from proof of work to proof of stake. This is like when they changed their consensus mechanism. So now it's not like a competition of computational power to produce blocks for the network. It's more about like having stake assigned to different nodes and then rewarding or punishing them based on them acting good. So yeah, this reduced their energy consumption by 99.95% if you saw it in news, but we won't go too much over the reasons why. I'll just take it as it is. So Ethereum uses proof of stake now. I know a lot of you probably know what it is, but I'll just go over a brief overview. So with proof of stake, people run validator nodes to secure the network, and then they put money behind these computers that are the validator nodes, and that's called the stake. And then when the computer does good for the network, acts honestly, does its job on time and all things like that, they get rewarded. And then if they do something bad against the rules, or they're late, or they're offline when they're not supposed to be, they get slashed. So that money that was put on it gets deducted. So the first barrier to running a validator, like if you wanted to set up your own computer and then provide this service for the network, it costs a lot of money because that stake that I mentioned that you need to put onto the computer basically is 32 ETH, which is the equivalent of $80,000, and Wojak cannot afford that. So basically what people came up with is like, okay, what if we just gathered 32 ETH from a group of people, right? And then we can collect it together, and now we have enough to run a validator. And then once this computer is up and running, and then it gets rewards, then we can, I'll take my cut for running the computer for everyone, and then I'll pay back the rest of the people, the rest of the rewards I got based on how much they contributed to that 32 ETH. And then something else that I'll get into is like the representation of how this works. So like if you contribute 16 ETH to the bundle, right, what happens is you stake 16 ETH, and then you get back this representation called a liquid staking token. And then if you do it through a protocol called Lido, what it is this ST ETH thing. People just call it STETH. So yeah, that's what you get back when you stake your ETH through a protocol like Lido. So yeah, so I'll talk about why this STETH representation is actually important. So like I said, the amount that you contribute to the bundle is represented by your STETH. So we had to give 1 Ethereum in order to get 1 STETH back to represent how much stake we actually did, because we're just denominating it in a way that we're not doing it in units of 32 anymore. So through Lido, there would be like, yeah, the subcomputer, and then take 32, stick it on one. So yeah, because you had to give 1 ETH to get 1 STETH, 1 STETH essentially represents the value of 1 ETH. So what people do is they start treating it like it's just plain ETH, because there is real ETH backing this token, right? Like it's not just you made it out of thin air. There is something behind it that exists that gives it that value. And so what people can do is they can use it to swap for stuff. They can use it as collateral, just like how they do with normal ETH.
Can you buy STETH without staking?
Yeah, you can buy it from somebody else.
Is STETH liquid? Like, can you transfer back to from Lido, or is it a security locked up?
Technically, it is, but it's been abstracted in a way where you can just essentially trade it like liquidly. But if you had no way of like swapping with people, right, then no, you would have, there used to be actually a lockup for that, and then a lot of it was completely locked and people weren't able to redeem it back, but now you can. Yeah.
Could you, so you could buy ETH off of someone and then redeem the ETH with that ETH without being the original person to stake it?
Yeah, I believe so.
Yeah, there was no queue then that long, right?
Oh, I don't know about the queues anymore, but when it first opened up, I think like about a year ago, there was a long queue, yeah. But I'm not sure about the queue.
Days now, right?
Probably.
Yeah.
Hmm. I don't know about that. So yeah, aside from those two things, what if people found other ways to do, other things to do with the ETH? And this is what I'm going to get into about restaking. So I'm going to explain this more, but the high-level idea is that they can use restaking for security, specifically securing things like that are other than the Ethereum network, which I'll get into, and then they can be rewarded for providing that security. And if you ever see the phrase crypto economic security, this is the kind of realm it's referring to. So a new world and a new market emerges from something like this. So I mentioned that another use you can use it for is providing more security, right? But what exactly are you providing more security for? Think more about this. We'll think about where we already have security. So you'll probably see this kind of idea around a lot, that smart contracts built on Ethereum inherit the security of Ethereum. So what does this really mean? If you imagine a mall, and then all the stores in a mall are like smart contracts, and the mall itself is like, the Ethereum network, the mall has like mall cops, and it also has other forms of security, right? So if you open your store inside of this mall, you kind of inherit the security from the mall because if something happens, the mall has security to help you out. So smart contracts and Ethereum can inherit that security from that vast network of validators that runs Ethereum. At this point, it's about 900,000 of them. But not everything is a smart contract. So not everything can take advantage of that 900,000. So examples of this are like infrastructure things, roll-ups, oracles, bridges. And these are all things that can benefit more from security because they don't inherently get it from Ethereum. And so they've had to find their own ways to do that. So how have things like this bootstrapped their security? Well, a lot of the times they're also using like proof of stake or something like that, but the consequences of this are, say I had like a new network, right? And then I want to stake on that in order to gain rewards on this network. If I only had like 32 ETH of value and I was staking on Ethereum, if I want to stake on this other network, I don't have any more money. So I would take my 32 ETH off of Ethereum. So I'll take it off of securing Ethereum and then use it to secure this other network, right? So there's this notion of like moving capital out of Ethereum to secure something else. You can't do both at the same time. And in order to incentivize people to move away from Ethereum, secure their own thing, they're going to launch a token, give you crazy incentives. You see these numbers, you see these pumps and dumps, you see lots of shilling of these things. That's kind of like a very common pattern that we've seen. So that's how these things have, a lot of them, chosen to bootstrap their security. So how can we do this better? What if there's a way of leveraging the Ethereum validators, the 900,000 of them, to not just provide security for Ethereum, but also other things on the Ethereum ecosystem at the same time? And that'll be EigenLayer. So I'll talk about that now. So here's a picture of one of the graphics they have in the white paper. So I'll take you back to this idea of the security that we talked about earlier. So let me put this up. Oh, it's very faint. Okay. But that left block, the blue block Ethereum, and that vertical arrow up to that black bar, that is like the security you get for smart contracts. So imagine the black thing is like our application, and then it's running on Ethereum. And those three green boxes are other kind of services that it depends on. So if my black application was something like a sports betting application, one of the green things could be an oracle that's like feeding me information about like the result of a basketball game or like the stats of the people in that game. And then the dollar amounts underneath them are just like example numbers of how much backs them. So in this like little world we have here, there's $10 billion of stake securing Ethereum. And then for those 3 services that my Black application depends on, there's $1 billion securing each one. So if we think about security, there's 4 different ways of attacking my application, right? You can either manipulate Ethereum, or you can manipulate any of those 3 services that my application depends on. So like, I could take control of one of the green things and like propose some fake result of like, oh, like this team lost to that team, but that may not necessarily be true, right? And then that would mess with my application. And it's relatively easier to go that path to attack me, because with Ethereum, there's a lot of stake that you have to overcome to attack, whereas like for these services, there's a lot of fragmented capital and just, you know, lower, just a lower barrier to attack. And then on the right side, this is a picture where we take all 13 billion in the little world we have here and then stake it entirely on Ethereum. But at the same time, that 13 billion is going to secure this EigenLayer concept that I'm going to talk about more. And then that secures those 3 services that my application uses. So you can't attack Ethereum because it costs so much to do so. And at the same time, you can't attack those 3 services anymore because now there's 13 times as much securing each one of those services. But we're not done with that yet because it looks too good to be true. It looks so good and so efficient, but the reason why is because they're double dipping. If you look at this left picture, there's $10 billion securing the Ethereum line and then 1 securing the other 3, right? But in this picture, you have 13 securing that vertical line, and then you have 13 securing the 3 services over there. So you essentially have like 13 billion securing this, and another 13 billion securing the AVSs, or the 3 services, we'll just call them. So you have like $26 billion of security when the system only had 13, right? And this is what they call restaking. So this is the concept of restaking, where they're basically reusing that stake on Ethereum to use that to secure other services that we're using. So we'll explain how this works more practically with an example. So one of the bigger things that are launched on EigenLayer is something called EigenDA. DA stands for data availability. It's just like the ability for nodes to access specific time or data on a blockchain at any time, so they can replay like information from a specific point in time, certain block information that they want. It's like having a guarantee that if I ever want to access that kind of stuff at a certain time, I'll be able to get that. So that's called data availability. And then we want nodes to secure this data availability layer. So if I'm a developer of this EigenDA thing, I can launch it as an AVS. That's what it stands for actively validated services. That's what those 3 green boxes you saw earlier are. So I'll launch it as one of those things on EigenLayer. And so how the validators actually provide security to this is that these existing Ethereum validators are basically computers, right? They're running software to validate for Ethereum. They could be willing to do more work for more rewards, right? So what happens is they can opt in to perform validation tasks for my EigenDA application. So they can opt in to validate, so they can opt in to perform validation tasks for this EigenDA application that I have. And what that means is on these computers that are already running software to validate for Ethereum, they're going to run additional software to validate stuff for my application, which is this EigenDA thing. And then they can be rewarded for that, just like a normal proof of stake. So they're going to run more validation stuff, not just for Ethereum, but also this service that I've launched on EigenLayer. And they'll be rewarded for doing good, and they'll be slashed for doing bad. And when they do this, they become something called an operator. So we're going to bring back the idea of this LST, the Steve thing again. So we can actually use these for the EigenDA service as the stake that we put onto them to earn rewards. And then we'll think more about like the double dip here. So first, somebody stakes stakes ETH onto Ethereum, and then afterward, they're going to get this LST representation, right? So they're going to get the equivalent amount of stETH that represents how much they staked on Ethereum originally, right? But then now that they have this stETH, they can actually use this stETH and stake it on other things. So there's 3 other AVSs here. I can put, like, if I had like 9 stETH, right? I can put 3 stETH to secure AVS A, another 3 to secure AVS B, and another 3 to secure AVS C. So I originally had 9 that I staked on Ethereum, and I get 9 stETH back to use again to provide stake for 3 other things. And so that's what it means by restaking, the act of taking this LST and staking it to other things. And that's pretty much it. So just to recap what we talked about, people basically came up with a way to democratize Ethereum staking after the merge, which is like going from proof of work to proof of stake. So you don't need 32 ETH to stake anymore. You can have any amount less than that, and then you can just bundle with other people. And LSTs are a creative way for us to do that. And EigenLayer found another use case for these LSTs. So we can use those to basically create security for other things on the Ethereum ecosystem that are not just smart contracts. So we can leverage this vast network of like 900,000 computers and get them to do a little bit more work to provide much more security for our applications. So we don't need to bootstrap it ourselves via means that are not too optimal. And yeah, so we also have a way of simultaneously providing stake for multiple things using the same capital, and that's called restaking.
So is EigenLayer making a platform where it can take ETH and then like do some sort of validation for like different services? Because like, wouldn't you need to set up something different for each different service that like takes ETH and then does a validation for that?
Yeah, so there's 2 pieces to that. One is like they literally make a smart contract that's going to take the stETH. And the second aspect of it is when you become an operator to run more software, that software that it's doing will have implications on like the stETH in that smart contract being slashed or rewarded.
So does the software that the operator runs, does each operator choose what services that you're restaking for?
Yep, you would opt in, or yeah, you would opt into services on EigenLayer that you would want to validate for.
EigenLayer is setting it up to work with all these different services. That's their position.
Well, yeah, there will be services that exist on EigenLayer, and then there will be operators who can opt into the ones that they want to do extra validation for.
Is it only Lido right now?
No, that was just a simplest example.
So what is EigenLayer? Which LST? Is it the whole suite?
Actually not sure which specific ones. I'm sure there'd be not just Lido.
I'm just thinking about like the inheritance of like security.
Mm-hmm.
It's like if you're using Lido, right, and then there's a problem with Lido, so like it's a rocket pool exploit, like,
Yeah,
right?
that's a good point.
So now if rocket pool is exploited, like now we don't just lose, some security on the
Yeah, if there's a problem with that like LST representation that the EigenLayer stuff relies on, then yeah, exactly.
everything would go insane then in that scenario, I think.
It'd be a pretty bad situation. But I think it's more than that, right? Because LSTs are like billions and billions of dollars, right? Even if we're not even considering the implications for EigenLayer, think about like the amount of money that like is just forever locked up or just unable to be reobtained. Yeah.
When your original ETH gets slashed,
Mm-hmm.
you have like this set of ETH restaked for something else. How does the reclaiming work? So is it like, say you have X ETH that you slashed, and you got X ETH for that, or X ETH that you staked, and then you have X ETH for that, and then your ETH gets slashed. When you bring back those ETH, do they just give you that, like, the amount after it got slashed?
So I think for this, because when you're doing this like liquid stake and stuff, it's not actually you who's running these validators, right? And so the person who's doing that is taking on some kind of risk, right? So they're probably doing it on a large scale, and they're taking a bunch of ETH from people to, you know, put on these validators. When they get slashed, that's usually abstracted away from the people they originally got that money from. And in another way, like there's like insurance policies that have kind of come up in this as well. So like if you were to do it by yourself, you get the full like interest reward for doing that, right? But if you do it through this, you get slightly less because the person actually doing and setting up this like validator has to take on some kind of risk, right? So they take a cut of that. So I think in that situation, it's abstracted away from you, but realistically, if you did it by yourself, then yeah, that'd be a concern.
So you never actually see your ETH getting slashed.
You wouldn't, as like a normal user of like an LST. Okay. So yeah, Rohit will now talk about some risks and repercussions of EigenLayer.
So I don't really have anything prepared too deep, but there are some existential risks that come with EigenLayer that people also have been talking about, because it's kind of a cool idea to say like you can kind of boost your earnings, and it seems pretty safe, but there's a lot of risks, obviously, because higher reward is usually associated with higher risk. So I guess the first thing is that because a lot of people use LSTs almost interchangeably with ETH, it trades one for one pretty much everywhere. People will start to forget that they're using a representation of the staked token. So what that means is that if somebody starts to accept STETH, or the liquid staking token, as collateral for a loan, it can lead to this like cascading effect where, you know, let's say I borrow or I stake 100 ETH, I get 100 STETH, and then I go to someone else, one of those people that were just listed up there, and then I give them 100 STETH, and they're willing to give me like 70, you know, whatever the price of Ether is, 70% of that in USDC. Then I can go to somewhere else, I can buy more Ether, I can stake that again, and I can just keep doing that loop over and over and over, basically boosting my earnings, which is technically possible with EigenLayer, and it's something that I've heard discussed from Sriram Kannan. So the problem with this is that, you know, it's kind of cool because you can earn a lot more money, but the downside is that you're a lot more risk exposed to a volatile market. If the price of Ether just suddenly drops below your threshold, you're not just getting 100 Ether liquidated, you're getting, you know, some multiple of that 100, of your original 100 Ether. And that can lead to a larger price drop, which can lead to cascading market effects. You know, somebody else might have a threshold just below yours somewhere else, and then they get liquidated because of your actions, and that goes on and on. So that's kind of a high risk play, and it's one of the existential threats to Ethereum that could arise from EigenLayer. But the overall, like, I think the biggest takeaway is that there's this separation of technical and, what is it called, social consensus. So there's a technical consensus, which is a consensus algorithm, proof of work, proof of stake. But then there's also the idea of social consensus, because what happens when, you know, 90% of people lose all their money is that they get really pissed off, and then they start trying to figure out a way to fix it. And it's happened once in Ethereum's history, is that they had to roll back the chain, and it was incredibly unpopular. And it goes against a lot of blockchain ethos and a lot of blockchain philosophy about how to build a society. And so that's the difference between, you know, social and technical consensus, that the technical consensus is like, okay, well, let's mine the next block. But then the social consensus is like, if we're going to fork a chain, which fork are we choosing? Are we choosing what if there's a bug that happens on block 100, and we've mined up to block 110, And now we want to like go back to block 99 and like replay that so that we don't, fix the bug and replay the next 10 blocks. There's a lot of problems that can come out from that, and blockchain people don't really like that idea at all. So then there's the social side of this thing this blockchain is like this thing that we all agree on, but it's a people at the end of the day that are saying that, okay, this is the source of truth for our money overall. So the big takeaway from the EigenLayer risks is that you want to avoid having to rely on the social consensus and putting other people at risk. So, like if your protocol, what was it? If your protocol is creating like, if you make a protocol and things blow up, you don't want to have the Ethereum consensus chain bail you out, is essentially the idea. You want to keep the damage contained to just your protocol. And that was with the example of restaking the ST-ETH. It was something that you could go to, you could take ST-ETH and then go to something like Compound or Aave, and then now you're affecting Aave's process, as opposed to just keeping the damage contained to your protocol. I did like this one example of a low-risk use of EigenLayer, which was a way for Dogecoin to switch to proof of stake, which this is from Vitalik's blog. But as an example, he says, okay, what if Dogecoin wants to use EigenLayer to switch to a proof of stake model instead of proof of work as it is right now? What you could do is you could say, okay, well, let's have all the Ether stakers that want to join the, it's not going to be everyone, but if you want to join this Dogecoin proof of stake pool and you're staking your Ether, you would change your stake from wherever, the staking address would be from wherever it is now to a new smart contract. And that smart contract would then be tied to the Dogecoin blockchain. So that way the Dogecoin chain can adopt the security model of the Ethereum proof of stake and this giant staking network. That way, if now it's that if I've staked to the smart contract and I violate the rules, not on Ethereum, but I'm on the Dogecoin network and I violate the rules, my stake on Ether can still be burned. So I still lose Ether for doing something on the Dogecoin network. And I thought that was a cool, it's considered a low risk protocol, or that's a low risk kind of use of EigenLayer, but I thought it was a cool use case because, it's a little more, it's less abstracted and it's a little more practical. And it's cool to be able to see we can adopt this proof of stake for a completely different chain, that's usually completely separate. You could also use it to, there was also an example of verifying ownership to say I've staked, if I've staked Ether on Rocket Pool or something, and I have this ST-ETH, I can go to a social media and it's like the blue check mark kind of verification. But I still don't understand that one actually. If that makes, because I don't know why you would need an LST for that. I think you could just sign with your secret key.
Wait, what was that example then? You said
Yeah, the example is verifying ownership of a validator key for a social media verification that I have a validator key. So I can get a blue check mark if I can cryptographically prove that I have staked 32 ETH.
So are you staking that ETH with the social media platform?
It's just a proof.
You're just showing them that you have some amount of.
Yeah, but I don't. That was given as an example, but I still don't see why I can't just sign a message under my secret key, and they could, my public key is public, so everyone can see that this key has staked 32 ETH, and then they can just check by decrypting under that public key. I don't think you need an LST for that, but there's probably something I'm missing. Yeah, and that's pretty much it. There's there's a million different uses. There's Oracle problems of using liquid staking tokens as a way to come to a consensus around a oracle, like a pricing oracle of what's the price of Ether and USD, or Ether in Chinese yen. And then if 90% of people start staking to that, or taking their LSTs and then putting it on the oracle, or providing validating services on the oracle, they're vulnerable to manipulation. But a lot of that comes down to like centralization of ownership of the stake and spillover effects of your protocol to others, because obviously Oracle services are used by other protocols. So you want those to be decentralized. But that's about all I got. Oh, yeah?
I have a question about, so you mentioned the price drop, like at the beginning.
Mm-hmm.
I see you talking about the price drop of Ethereum.
Ether, yeah.
Why would there be a price drop if there's stashing?
So the example was like, let's say you start with 100 ETH, you stake it, you get 100 ST ETH, and if another protocol like Aave is accepting ST ETH as collateral for a loan, I can take my ST ETH, I can go to Aave, I can take a loan out against this staked ETH, and then let's say I get 150 bucks, or 50 bucks for it, 50 bucks for 100 ETH or whatever. And then I go to somewhere else, I buy 50 ETH, and I go and I stake it again. So now I originally had 100 ETH, but now I'm staking 150 worth of ETH. So the price, like, so if my original 100 ST ETH gets liquidated, that would drop the price a little bit, like some delta amount.
Of Steve.
It's priced in ETH.
It's dropping the price. So you borrow an Aave,
Mhm.
and then it gives you a liquidation call that says, just to make it issue, we're going to go through auction now.
Mhm.
You can start auctioning off the Steve.
Mhm.
Steve price then drops.
Mhm.
But that Steve is still claimable for actual ETH from LIDA. And then this is where the price drop of Ethereum. There's no actual sale of like wrapped ETH. It's the sale of Steve, which is exactly
Yeah.
wrapped ETH, right?
Yeah, and then LIDA would be taking the risk in that case, right?
The LIDA is denominated in ETH, so there's no like USD basis.
Yeah, I guess the example I gave was a little simplistic, because then you'd want to have instead of 50, I guess you need to involve dollars somewhere in that chain of custody.
But not if it's self-contained. I don't see a reason for it. Only when you involve Aave does it start being risky.
Yeah. I mean, that's the idea of the spillover, because it's that other people are insensitive to the ST ETH versus ETH because it trades pretty similarly. But yeah, it's once Aave starts taking it as collateral, or if someone else does. I think that's the idea.
But not EigenLayer necessarily in this case then.
It would just be LSTs in general, yeah. But
Right.
yeah. That's all I got. Yep, cool.